Hey, this is Dr. B, and let's talk about polyvalent ions. Those are the ions that can assume more than one charge. This arises primarily due to the fact that the D block is always going to be one shell under the S block, and oftentimes will be unfilled. This leads to multiple ions being possible. If it were always filled, you'd just lose those valence electrons, but complicating things is the D and occasionally the F block that is unfilled, and that causes things to be polyvalent. Here's a periodic table, and it shows a lot of the common polyvalent ions. This is kind of handy because, by and large, these are the ones that you have to worry about. However, it does create a problem because, in truth, some of the other ones have rare ions that they form as well. So how do you go about naming these things? Let's take a look at them in detail. Take a look at titanium, for example. There's its electron configuration. Notice that it has two valence electrons. But notice also that rather than having a full set of 10 d electrons in the third shell, it's missing 8 of them. So these want to leave, and perhaps these would want to leave too. So we've got close energy levels. Nobody usually goes into any kind of mathematical analysis of predicting what would happen. They just see what's observed. Those unfilled inner shells cause issues. To name them, we include the charge. I think that's a good system. So if you've got titanium 4 chloride, that is TiCl4. Nice, right? Use Roman numerals. If it's TiCl2, it just perhaps lost those 2 electrons, and that would be titanium 2 chloride. All right, apply this to iron 2 cyanide, and that must mean that we have Fe with a plus 2 charge. Each cyanide is minus 1, so you need 2 of those, and that is iron 2 cyanide. Don't take it too far, however. See sodium chloride here? We wouldn't call that sodium 1 chloride. It's monovalent. Which are the ones that are monovalent? Group 1, always. Group 2, always. Things that lack the D blocks going up to here. And, sometimes people point out the diagonal. Aluminum, zinc, and silver are plus 3, plus 2, and plus 1 exclusively. They don't typically have a charge, but it will vary a little bit from teacher to teacher. Hopefully they're being generous, and so the ones that are potentially polyvalent, it's okay to include that charge. People would appreciate it. It makes it easier to name anyhow. So that's polyvalent ions.